question.
Okay.
Oops, sorry.
I already started recording.
Are you going to show how to package um, from the source, how to package so you can run it as separately from IntelliJ?
Uh,
Standard.
I can do that.
Hello.
Yeah, I can do that. I will have to. I think I have here. Yes, I have. Let me talk. Yes, I can share. I can share the package. Let me see here.
I think that will be a worthwhile piece of information, you know?
Yeah, I can share that. I think that what is on Slack, on GitHub, let me check. On GitHub, uh, okay, this is the source package. Everything that I have is here. All right. So these are the Java files. See, so you can download these guys and just upload it to IntelliJ or any other IDE that can that is compatible with Java, and then you can run it. This is just the source file. Source files is here.
Yeah.
Everything is here. Right? And I'm not planning on removing that. So you can, what you can do is just clone this to your computer. You copy this guy, right?
Yeah, I've been doing that. I do have it on.
Okay, you can clone it after Thursday. There's gonna be any, there are not gonna be any other modifications after Thursday. So, because when you fork it, you just grab it all, you just get all the updates onto that moment, right? Whatever happens later is not updated in the fork, right? So when everything is done, or what you can do is just clone it, and every time that I upload something, do a git pull instead of a git push. What I do is a git push, but you can do a git pull, and you get an updated version of the code in your computer. Okay, so here I just have, right, I just do git clone and then the repository, right? Or you can do a git pull. Once you have it in your computer, right, what you have to do, just git pull, and it will update it for you. Okay? Every time that I make a change. If you want to wait, you can wait until we finish the class and then do a git clone, and that's it. So this is exactly what I have in my computer. And these are the files that you can run because they have a .java extension, right? Okay. So today's class is going to be a short one, but we're going to see more about exception handling, right? And how we can, deal with exceptions, because the exceptions are super important, right? And you want to know what to do when an exception may arise in your program. So you don't want your program to crash. What you want is your program to catch the exception and continue running. So you want your program to deal with the exception and continue running. Okay? So let me create a class real quick, and let me call this class understanding exceptions. Okay. So let's see an exception here so you guys can understand a little bit more about exceptions. So I'm gonna say int. You guys know what this is, right? That's an array, right? So when I create an array, you int, and then we're gonna see that the array contains two size 2, right? Now if I print this, right, and I say my array, I want to get the element with index 5. Okay, so guys, you already know that this is going to throw an exception, right? And the exception name is index out of bound, right? Array index out of bounds exception. Why? Because this only has index 0 and 1, not 5. So if I do this, I'm going to get 0, right? Because the array is empty, right? If I do 2, right? I'm sorry, 1, we're going to get, and this is 0, I'm going to get 0 as well. So basically this array, if I print it, we can do this, right? And then I say my array, and then I should get 0, 0, right? That's all we get, because this array is empty. So element 0 is going to be 0, and element 1 is going to be 1, okay? Unless I do something like this, like my array as a 0 equals 2, right? And then I'm going to have a different output. It's going to be 2 and 0, right? And maybe I want to do my array 1, 10, right? And then we're going to get 2.10, right? If I try to add something like this, right, I'm going to get an exception because I don't have index 2, right? But what if I do this, right? Can I reassign a value? Of course I can, right? I can reassign a value, but I cannot extend this guy. So I can reset a value, but I cannot add or remove values. So this guy doesn't have a remove guy. You see? It's not like a list that you can resize it and do whatever you want. But an array has a fixed size, right? We only have 0 and 1 indices, okay? So that's an exception. So we understand what exception is. It's just when the program doesn't know what to do with something, right? And then it will throw an error. This is, I don't know what this is, right? It's like dividing by 0. That's undefined. So it's going to give you an exception that say division by 0, okay? Exception, right? So you have to be able to catch that exception and not let your program crash, right? And continue running, continue working. Imagine if you don't, if those systems, big systems that you have there out there that people are using, like our phones, our computers, they don't have exception handling. They will crash all the time. Things happen, but your system has to be able to deal with exception and continue to be operational. And that's what we're doing here, right? Now, there's a concept of checked exceptions, checked versus unchecked exceptions, okay, in Java, right? So a checked exception are the exceptions that are checked at compile time, right? If some code within a method throws a checked exception, then the method must either handle the exception or it must specify the exception using throws, the throws keyword, okay? And we're gonna see that later. For example, consider the following Java program that opens a file, a test.txt, and prints the first 3 lines of it. The program doesn't compile because the function main uses file reader, and file reader throws a checked exception, file not found exception. Okay, so it's good to know, guys, what are some examples of checked exception and what are some examples of unchecked exceptions. Okay, so, well, and now you can start thinking that file not found is a checked exception. Okay, let me see here, another one. Unchecked exception are the exceptions that are not checked at compile time. In C++, all exceptions are unchecked, not in Java. So it is not forced by the compiler to either handle or specify the exception. It is up to the programmers to be civilized and specify or catch the exceptions. In Java, exceptions on the error and runtime exception classes are unchecked exceptions. Everything else on the throwable is checked. Okay, throwable is a class. It's a superclass of all errors and exceptions. So all of the errors and all of the exceptions come from the class throwable. Okay. Now, what is the difference between an error and exception? An error is fatal. You cannot recover from an error, but an exception you can handle it. Okay, and that's what we're trying to handle today, an exception, right? So only objects are instances of this class or of its subclasses are thrown by the Java virtual machine or JVM, or can be thrown by the Java throw statement. So we can use the throw statement. Okay, now throwable, right? So we have the throwable here, the thrower class, and then you have the other classes error and exception that come from throwable, and then the ones that come from error are the unchecked ones, right? And then we can have exceptions that are right, can be checked, and runtime exception. So so the checked come from the exception class, and the unchecked come from the runtime exception. So let me see one example here. I don't like this guy. This guy is confusing. So throwable. So throwable, let me see one that is not confusing. So we have the error here, right? Yeah, but I want one that shows me the checked exceptions. Right here. So throwable, error, and then unchecked errors. And then here we have the exception. So exception, the checked exception come from the error exception class, and the unchecked exception come from the runtime exception. Okay. Now this one extends exception, as you can see here. But the checked exceptions come from the exception class and the runtime. So let me see examples of checked and unchecked exceptions, because that can show in the exam. Okay, so let me see if it gives me some examples of the ones that, let me see here. Let's see examples here. So checked exception can be I input output exception, SQL exception, mod form error exception. Unchecked exception can be null pointer exception, number format exception, class cast exception, index out of bounds exception. Okay. Another example of checked that we saw it already is class not found exception, our exception. So, and give me runtime exception, arithmetic exception, array store exception, class cast exception. So I can post this because in the exam, you may have to probably identify if the exception is checked or unchecked. Now I want to probably take a picture of this, right? And then paste it on Slack. Okay.
Are these exceptions coded do they have a code, a number code, or
Yeah,
some sort of a code?
you can have a try catch. With a try catch, you can handle the exception. And also, if you read here, let me see, where is it? What we saw. Okay, where was it that I saw here? Okay, where's the file that I had before? Where is it? Did I have something before? I think it was here. Okay, here. Okay, so checked are the exceptions that are checked are compiled time. If some code with the method throws a checked exception, then the method must either handle the exception or it must specify the exception using the throws keyword. Like here, for example, let me see if it's just here. You're dealing with files, so this is a checked exception, right? Like file not found, like here. You see? So you have to foresee that, right? You have to foresee it. You have to think that the file may not exist, right? When the user tries to find the file, right, and trying to get the content of the file, probably the file on the computer doesn't exist. So you have to foresee that and handle the exception in your program, right? So your program doesn't crash. Okay, let me see if it does here. You see here? So
Where do you buffer that? Okay.
So you see public in the main method, and then you say throws IO exception, just in case it happens. So because you're getting the file from this from this from this, and you see that this is the path to the file, but probably the file doesn't exist, right? Probably someone deleted it. Someone deleted it. So you have to be able to throw that exception, like the file doesn't exist, but your program doesn't crash, right? Your program doesn't crash. It just catches the exception, right? So, one moment. Okay. So let me see here. This is, for example, an arithmetic exception. And this is an unchecked exception, right? This is the one that when you divide by 0. So you have here this program that has of x equals 0, but then you say y divided by x, right? This will throw an exception, which is an arithmetic exception divided by 0. But if you're able to catch that, just foresee it. Okay, I'm asking the customer, the user, to enter two numbers, right? What if the customer or the user enters the second number, which is the denominator, as 0? So I have to foresee that and think, well, if that happens, I have to be able to just handle that and continue operating, right? If you don't handle the exception, your program will crash for sure, because it will throw an exception, right? But the exception will be thrown, and you have to be able to catch it, right? It throws it, and you catch it, and when you catch it, you deal with it. You print something like division by 0 is not accepted, but your program doesn't crash, right? We're going to see some examples now, right? Okay. So let me put a program here, right? Like, let's say checked versus unchecked, right? Right. Now I'm gonna say PSVM, right? And I'm gonna say throws exception here, right? I'm just using the word throws exception, right? So I'm gonna say method, my method, because this is the guy that detects the exception and it will throw it, right? And of course, this is a method that I have to create outside here. And of course, it has to be public, right? Static, and it's gonna be void, and I'm gonna call it my method, right? Static because, you know, it's being called from a static content, right? So I'm gonna say this, and then I'm gonna say, and of course, this one would say throws an exception as well, right? And then we can say, okay, so I can say new throw new exception. That's a class, right? And we say fail to load. These are just examples, right? Remember, you use the word throws in the method declaration, right? And you use the word throw in the body of the method. Throws and throw. We're gonna throw an exception here. We're gonna say the message of the exception is gonna fail to load, okay? And this is just an example, okay? Let me create another method. I'm gonna say static void, right? And we're gonna say another method. We're gonna say throws runtime exception. Okay, that's another class. We take a look at this guy here. It's just the one that handles the unchecked exceptions, right? And section is for checked exceptions. Remember, we have some examples of exception, right? And we have some examples of unchecked exceptions, depending on the exception that you're trying to catch. Throw new runtime exception, and then we can say run parameter. Just an example, right? Now we can run this, right? And then we get just an exception because we're throwing the exception. Why? Well, we're calling this method here that will throw an exception, right? So we just, if we remove this guy, we have a problem because this method, it's throwing an exception. So the one that is calling has to be doing that too, right? The one calling is the one throwing the exception, right? And this one is the one receiving that. The call of the method has to have this as well. If we just remove that, we have a problem because there's some certain connection between this method and this method, right? So now we just put it here. But remember, when we call this method, what we're doing basically in this body of the method is just calling the class exception and throwing this exception. That's why it says fail to load, right? Fail to load. I can say, for example, another, but this one, right? This one doesn't have the exception here is this one. So I can do this, and now I get the runtime exception. It's just the one that I call, right? One that I call. As you can see here, it doesn't have to be the same exception, right? Remember that if we take a look at this, they both come from the exception class. You see? Exception class. That's why they're compatible, because runtime comes from the exception class. Okay? But basically, we're just calling this method here, and then it's throwing an exception. We're just forcing the method to throw an exception, right? Just forcing it. And of course, this one is unchecked, and this one is checked. We don't have the exception as such there, like output, input, exception, or some file not found, or something, not anything of that, but we're just referring to the class where the exception is coming from, right? The checked exception comes from exception, and the unchecked exception comes from runtime exception. Okay, we're not dealing with errors, we're dealing with exceptions, and they both come from the throwable class, superclass. Okay, so let's leave it the way it was before, right? And we're just working with this guy. Okay. Now,
I have a question.
go ahead.
So this throws exception on the main. The word exception itself is actually calling a what? What is that calling?
No, we're just telling the Java version machine that this method is throwing an exception when it calls the other one.
Yeah, but the word exception itself, which is in blue, put your cursor over it. What is it?
Exception is something wrong is going to happen.
No, I understand. I think I understand the concept of
what do you mean?
Of the errors and the exceptions. I just want to know, if you put your cursor over the word exception, how is it going to define it? Can you right click? I don't know how it. Sometimes it shows you what it is. Yeah.
Remember, the compiler will read all this, and it read this is a class. This is not just a word. It's a class.
Okay, so it is a class. Okay,
it's a class right there.
That's it. This is what I wanted to see.
Yeah, you see it on the screen.
Yeah. I see it now.
And if you see
public class exception,
class that extends throwable, right? It's a class that extends throwable. A throwable is a superclass. Right?
Can you go back for a moment? Oh, I want to see that. Can you right click on it again? So the pop-up shows up. There you go. Apologize. Okay, got it. Thank you.
Yeah. All right. So let's deal with exception. Now we force this, right? Let's deal with exception now. Exception are not difficult. It's just we need to understand them. Okay. Let's deal with exception. So dealing with exceptions, right? Now we're gonna have the PSVM, right? Okay, PSVM, and then I'm gonna say int A 10, right? And int B 0. So in this In this case, we already know the values because this is hard-coded values. So later we're gonna do it dynamically, so you guys can just foresee it. Right now we know it. We know the B0, but you never know if the user has to enter the value. Okay, so we're gonna use the keyword or the expression try. This is the one that will try that would just test whatever's happening, and then it will always be, or almost always be, with the catch exception, the catch word. Okay, so right now I'm gonna put here the exception that I'm trying to catch. So I need to know that division by 0 is an arithmetic exception, right? And then I can see, just say, use the object of the class. Remember, the arithmetic exception, it's a class too. You see, it's a class arithmetic exception extends runtime. It means that it's an unchecked exception right here, right? It's the one that you can foresee. It's the one that is not checked at compile time. So you have to be able to foresee it, right? Foresee it. So I can use an object here, and this object contains a lot of things. So if I say e dot, I have a lot of things here from that object. Get message string, the stack trace. Stack trace is just the chain of events that happen when this exception is caught. Okay, all of these methods. This is just an object of the class arithmetic exception, right? It's an exception as well, right? So I can say sysout. I'm just going to handle the exception and say error dividing message equals, and then I'm going to say e.get message, right? So I'm going to get the message that is printed when this happens. Okay, so right now here in the body of a try, right, I'm going to say int result equals divide, and when you see this, immediately you know that there's a method called divide, right? And then we're going to say sysout result equals result, right? Now let's create a method divide. Why? That will return the division of these two numbers, right? So let's say public static, we return an integer, and then we say divide, right? And then we're gonna say int a, we're just getting two arguments, int b, right? What's going on here? Am I inside? Oh, I'm still inside the main method. That's why it's not working, okay? So main method is this one. So I'm gonna put it here, right? And then I'm gonna say, this is giving me an error here because it's expecting a return statement. Remember, this is returning an integer. So you have to have a return statement, okay? As soon as I put the return statement, it's going to, this red line here is going to disappear, okay? So I'm gonna return a divided by b, right? You see? The errors here is gone, right? So now this is going to return the division, store it in result, and then print that. But when this try knows that this return is undefined, because division by 0 is undefined, it's gonna catch the exception here, and the type of exception is arithmetic exception. You have to foresee that, and it's gonna print whatever is in the body of the catch block. Okay, so let's see it. Sorry. Okay, so if I just run this, I'm going to see that error divided message by 0. That's the message here, by 0. Okay, now let's see what happens if I don't catch that. So let me comment this, right, and comment this. All right, so I just took this out of the try block and the catch is not catching anything, right? So now if I do this, boom, your program crashes. You see how important dealing with exception is? Right now, it's throwing the exception. It's right here, by 0. So it is giving me the message, but not in a good, nice way. And it's just crashing. Your program cannot continue working, right? So let me just put it the way it was before, right? Right now, if I just do that, it doesn't crash. It's just capture the exception. Now I can continue here outside the try catch and say, let me create probably scanner input. Scanner. One moment. Scanner. This is to accept input from the user. Okay. We're just accepting input from the user. So we can say int num1, and then we can say like so enter number 1, just an example. And we can say int num1 equals input that next int, right? And we say, is this out? Num1. I'm just putting something here, just something for you guys to see how the program continues working, like nothing happens, right? You see, the program continues working, right? So you see, guys, it's nothing ever crashes. It's just continue running like nothing happened, right? You see? But like I said before, if I do this, right? If I just get these guys here, the program just crashes and it doesn't continue working, right? So that's why our systems nowadays, the systems that we use, like TVs, computers, phones, applications, they continue working when there's an error because they catch an exception, right? And then you don't have to deal with that after it happens. You can deal with that before it happens. And then
it's so elegant crashing.
That's right. That's right. So here I can say, right, enter number 1 and say A, right? And then enters number 2, right? And say B, right? Now I'm letting the user enter the number. How do we know that the user is not going to enter a 0? How do we know that? We're just letting the user enter the value. So we can say enter number 1, 2, right? Enter number 2, 5, and then the division, the result is 0. And why is this getting 0? And it's printing again. Okay. One moment.
Because it's an int.
So
by
Yeah.
divided by 5, it's point.
Yeah, it's an int. Yes. But let me see something else here. I have to make it a double so I can use it. Okay. Let me see something here. Okay.
You have to make the result of divide a double, right?
Yes.
And then the variable result also a double, and then you can print it.
Yeah.
I guess I'm paying attention, huh?
Yes, you are. All right. So let me make this result a double. And then here we're going to return a double. Oh, a double. Right. And here we're going to return double. Right. Okay. And I'm going to make this guy a double. And I'm going to make this guy a double. Right. And then I'm going to make this guy a double. Right. That's one way, right? That is one way. I can say 2, 1, and then 2, then we get 0.3333.
Yep, perfect.
Another way, yeah, that's a way and then I can say, for example, here, I can say maybe math, that round, and then this guy here, and I can say to probably round.
That's points.
And then probably here, round, double A. And here we're getting and expecting this guy here. And then we can say we get to 1 and 3. And then we get 0 again. So math round result, and then here too. This is not working here because this is an integer. Okay. Java.
Isn't it result, comma, 2?
Oh, that doesn't work that way.
I think you were outside of the bracket.
Yeah, no, if I do that, it doesn't work. Looking for math round, two sides. Okay. Here. Okay. Not time for that now. Okay. Okay, don't worry about that. That's not relevant right now. That's not relevant right now. So I could just have this guy and say, we say 5, 5 divided by 2 is 2.5. And then what I can do instead of entering here ln, I'll just put print, and then I can print one next to the other. So I don't have to, it doesn't go to the next line. So it just stays there, and then 2, and get 2.5. All right? But we are dealing with the exception, right? We're dealing with the exception here, right? We don't have to, whatever we continue doing after that, nothing happens. So if I just, right now, the second number is a 0, I can say 7 and 0, and then result infinity. So we get a result, right? We get a result, but it doesn't crash. So I can continue working or doing whatever I want. Okay. If I don't get that message, if I don't want to get the message, you can say, for example, division by b is not defined, right? You can say that if you want to. So I can say 7 and 0, and I get result. Oh yeah. It's getting this far here. It's not even catching the exception. Okay. Because the result is an integer. It's not an integer. Okay. So if we just leave it the way it was before, right? Then we'll be able to see that I can print whatever I want. Right? I just can print whatever I want. Right? Right? Now, if I just enter 7 and 0, then I get division by 0 is not defined. Right? This is another way you can do it. Right? Maybe you can cast that and say double. Right? And I say require int because this is an integer. Okay. Then we can say double here. And then let's see what happens now. If I say 2, then I get 2.0, right? Because it makes it an integer. It just come from here, right? It just come from here, and this is just require an integer because I'm returning this double here, right? Let's see what happens now. So if I do 5 and then I get 2.5. That's another way that I can do it as well. Okay, so I can declare these two guys as 5 of integers, as you can see, and then I can just have result as a double. But in the method, I have to return a double and just I have to cast this. Because I have this, this is not completely done here, so I have to cast it. If I try this way here, it's kind of unpredictable right now here. You see, you get 2.0. So I have to cast it to a double because that's what I'm returning, right? This is the return type. So if I now do it, right? If I do it now, like 8 divided by 3, I get 2.66666. Okay? Now, result is a double. So now if I can say round, and then see what happens now. Then I get 3. It just gives me an integer. So we have to find a way to just round it to 2 sides to the right of the decimal point. Okay. But now, if I do this 7 and 0, I get infinity. It's a different output because this is a double. The other one was an integer. All right. So guys, this is how you handle an exception in a program, right? Let's say that you want to enter, maybe you want to enter a string, right? But you enter an integer, right? And that is type Java format exception. Let's say that you want to enter enter a string and then you enter an integer, right? So you have to be able to catch that, to catch an exception. Okay.
It's a rounding mode in Java.
Let's say that you want to enter maybe here, if this try catch, right? Maybe you want to say integer choice. And we want to say sysout, enter integer, right? And then you say input, next, int. Okay. Now you want to have another. You want to have another. Another catch exception here, right? And you want to say probably number format exception number, and then you can say this is out wrong. Give me a wrong type. Okay. Let's see what happens. This is out. Choice. Choice. Okay. Let's see what happens. So we enter.
I put something in the chat, please.
4, and then integer, say class. And the input mismatch exception, that's the one. That's the one I want to see. Input mismatch exception. That's the one that I wanted to see. Okay. You put something in the chat?
Yeah. How to handle the of decimals.
Oh, 2 decimals? No, that's not a handle. That's not an exception. It's just how to do it.
No. I know that. It's not an exception.
How to do it. Okay, good.
How to do the rounding. Yeah.
So I can say 4 and 3, I get that, and I say class, and I say wrong type. You see? So that's something how you can handle the wrong type, right? So input mismatch exception is another unchecked exception, right? Maybe you want to handle index out of bound, right? Maybe you want to say, let's say, you say int my array just like the first program, right? My array. And then you say equals new array, right? Sorry, new int. And then we say, right? And now you want to say, maybe here, right? Sys out, my array, right? 4, right? So we can say my array, right? And now you can have another catch exception here that says array index out of bounds, array, and say your array index does not exist, right? So it's just handling that, right? Array index, just an example, right? So it's just handling that, okay? So now we can say, okay, so we just got this 7 divided by 3. We got this guy. We enter an integer, we say class, and then we say run type, right? And then it did give us the choice to grab the other one. The is out of bounds, right? And it just, okay, it doesn't print anything here. Choice. Integer. Integer, system out that, and okay, let me declare this here. Okay. And then 0, 1, 2. Okay. Not even reading that.
Kind of like a loop. Once it finds the error, exit.
Yeah. And here it throws the exception here. But here, maybe if I put it aside, just in another try catch.
Yep.
And then catch. I can put the catch, this one catch here. Okay. You can have as many try catch as you want, right? So enter number 1. Okay, 5, 2, and then your array does not exist. Enter number, and then it says 4, 2, 4. Okay. Okay. Division by 0. Okay. So this exception is not being cached because I did not be caught because I didn't enter a 0. Now let's enter a 0 now. 5 and 0. And then I get the array does not exist, result infinitive, and then I'm gonna enter class, and then I get run type. So it's just getting all the exceptions. Okay. So that's a way you can handle exceptions in Java. You just have to predict or maybe foresee a potential exception, and then you have to handle it before it happens. Otherwise your program will crash. That's guaranteed 100%. It will crash. Okay, and you don't want that. That's very ineffective. That's very inefficient, right? Very inefficient. Okay. So you guys understanding? Yeah.
Yep.
Okay. Let's deal with the finally block. Okay. So, guys, this is a block that will always be printed no matter what. Okay. This guy will never cease to be printed. Okay. The finally block. Okay. It's not a mandatory block, right? But you can use it to print something specific. Okay. Just in case you want to print something specific. It will always be printed no matter what. Okay. So I'm going to just create a string array, right? And name it array. And we're going to say new string, just like we've done before, right? We say array 0 equals John. John. Okay. Now we can say try, and then catch here. And then here, I'm going to say finally, right? So I'm going to have these three guys to here, okay? Now here in the try block, I'm going to say string element equals first to upper. That's a method that I'm going to create now. First to uppercase, okay? And then I'm going to pass the array. Okay, I'm going to create that method outside the main method. I'm going to say public static. We are going to return a string, and then we're going to say first to uppercase. We're going to pass the string array because it's here. We're just passing an array here, and the array is of a string. So I'm going to put here string array, and then I'm going to call it array. It doesn't matter. Okay. Whatever name I give it, right? Right? And now I have to return a string. So I'm going to say return array 0, right? Dot to uppercase. So I'm just grabbing the first element of the array. Remember that this is an array, So the first element is John. So what are we returning? We're returning the word John uppercase, right? And we're storing it in the element variable. Okay. So now we can say this out element, right? Element equals element. Now I'm going to say null pointer exception. And what is a null pointing exception? Well, the word says it all. It's just pointing to a null object, right? Let's say that there's nothing there, it's null. Okay, null point exception. Now we're going to say in the catch block, this out error. That's another type of exception, right? It's a null pointer. Okay. When the object is null, there's nothing, there's no value given to the object, then it's going to throw a null exception. Okay? A null pointer exception. MP dot get message. Now the finally block is going to say this out, right? And we're going to say finally block. You're going to see that no matter what, the finally block is going to be printed. Okay, so now if I just run this guy, well, I have to run it here. So if I run this guy, I'm going to get John, I'm finally blocked. So no exception is thrown, right? There's no exception here. Nothing is wrong. It's just thrown, and it's going to print this guy no matter what. Okay. It may catch all the exceptions before, but no matter what, it will print the finally block. So in the exam, when you see finally, it will be printed no matter what. Okay? So this is part of the program. We're going to continue after this is out here, right? So we're going to continue, say string str equals, we just initialize the variable as empty, this string as empty, right? So we're going to say try, and then we have a catch that's going to catch an exception. And then we're going to say, if the exception is caught, we're going to say str, and then we're going to concatenate sti with b, right? So the value of str is going to be v if the exception is caught. Okay? And finally, we're going to say str, and we're going to concatenate c. Guys, you can just guarantee that this is going to happen. No matter what the value of str is, it's going to add c. Because finally, it's always executed. The finally block, it's always executed. And then outside all of this guy is going to add d, right? And we say str, str. Okay? So we're going to say str equals this. So let's see what happens. Let's see what happens. We're going to have this C and D. You see, guys, there was no exception here. That's why it never printed B, right? I haven't had anything here yet, but I can say here str A, right? But this will not throw an exception. There's nothing wrong here. So if I do this, I get ACD. So after it grabs the element value, which is element equals John, it prints the finally block, always. Then it comes here, initializes str, the string, to empty. Then it says when it gets to the try class, the try block, it just concatenates empty with A, and then you start getting A. Okay, so the value of str here is A, right? So it comes here, it doesn't catch an exception. There's no exception here. Nothing happens. So it just prints the finally, and the finally, the str value is AC, right? And then it comes down here, it says, let me add a D to ACD. And that's why it prints str equals ACD. Right? Now, what if I do this? Int result equals 10 divided by 0. What do you think is going to happen? What do you think is going to happen? Let's see.
That's the exception.
Let's see. The value is B, C, and D.
Mm-hmm.
Why? Because it caught this section here. This is not executed ever, right? Then it jumps here. It adds the B because it caught the exception, right? And it comes here. It prints it finally. And it just prints this guy too. And you get BCD. Here, I can say arithmetic exception, right? And I can get the same thing. Remember that exception comes from, arithmetic exception comes from exception. So we can just from the general one, the general, which is the main one, exception, or you can specify what type of exception it is, right? We can use the class where it's coming from, right? Or you can have the class that specifically states the exception. All right. If there's no exception, the output is going to be completely different, or maybe somehow different. Okay, because the exception is never caught. There's no exception to catch. The exception is there. If something happens, so then it will catch that. If nothing happens, it doesn't catch anything. Right? Can I have a null value here? What if I do this? Error message is null. You see here? It caught the null pointer exception. But what if I eliminate this guy? Right? Or maybe there's no catch exception here. Right? You can have a finally with the try. Catch is not mandatory. What if I have that? Then I have an exception because the exception was never caught. I have a null pointer here. Your value is null. So it's pointing to a null value. That's why you get that exception. But if we have the catch here to catch the exception, what happens? Well, I can deal with it, right? I just get the message, but still my program runs because I still get the finally, and I still get this guy here. Okay? So you guys understand?
Yep.
Okay. It's 6:50. I think that we deserve a break. How about that?
I concur.
Okay, guys. So let's take a 10 minutes break, and let's be back at 7. Let me give you 5 more minutes. 7:15. 7:05. I'm sorry. 7:05. Okay, guys. So let's create another class. And this time we're gonna call it catching exception. Okay. So we're gonna create this guy here. Okay. And before the class, I'm gonna create another class and say class museum closed extend runtime exception, right? Okay. And the other class is gonna say class museum closed for lunch. Okay. And this one will extend museum closed. Okay. Good. So we have these two classes here. Okay. Now here I'm going to say try, and we're going to call a method called visit museum. Okay. Right. So I'm going to call them down here and say public static, right? Void visit museum. And for now, we're going to leave it this way, right? And then we continue with this guy. Okay. So we're going to catch an exception here. Okay. We're going to say museum closed for lunch, right? Museum closed. And this is a subclass, don't forget. Subclass. This is, remember, this guy extends museum closed. Okay. So we say this out closed for lunch. We'll come back in 2 hours. Okay. And then we're going to see catch museum closed. Right. And we're going to say sys out closed. Okay. So if we throw this exception, it's going to print this. If we throw this exception, it's going to print this. Okay. Now we continue. And then we say sys out calculate. And we're going to call that method. We're going to create that method. And here we're going to say public static string calculate. Right. And then we're going to say string result empty string str no. Right. And now we say try, and then try. We can have a nested try, okay? Nested try. So we can say result, and then we just have this guy, right? So this is result equals start, okay? and then we say str the length. Okay. And there is a result. End. Right? Now we're going to catch an exception. And we're going to say null pointer exception. We're going to say result null pointer exception. Right? So here the result is going to be start null pointer exception. Okay? If the exception is caught, right? It will do that. And then we're going to throw new runtime exception. Right? And we're going to say finally, result, finally. If you get to this point, your result is going to be star MPE finally. Right? And then we're going to throw new exception. Right? We do that later. Okay. All right. And then here we say catch, and we say exception. E, and we say result finished. Okay, so here the result will be star MPE finally finished. Right? And then after that we say return result. Okay. 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 So now we have this, and now in the Visit Museum method, we're going to say Boolean B equals math.random. So we're going to produce a random number. And let's say what this returns, right? If it is true, we're going to throw new museum, right? So it all depends of that number, right? If it is not true, then we're going to throw new museum closed for lunch, right? Okay. So this, if this is true, if the number that we randomly generate here is less than 0.5, it's going to come here and throw this exception, right? We're just forcing that exception there. Throw new closed, right? If it is the opposite, if it is not greater than 0.5, it's going to throw museum closed for lunch, and then it's going to print closed for lunch. We'll come back into ours. So everything depends on this guy here when this method is called, right? After this exception is caught, then it comes here and call the method calculate. Then in calculate, it's going to say string result and then null. It's going to say try. Result is greater, it's just concatenates with start. So the original value was empty, now it's going to be start. And this practically doesn't do anything. It's just, we're not even printing this. We're just not getting anything here, right? Because it's null, okay? So basically, what happens here, what are we doing here? So we're getting a method of what? Of null value. How can you get the length of nothing? Do you think that you can get the length of nothing?
Nothing.
You can get the length of Dooney, right? That would be 4, right? But how can you get the length of nothing? That doesn't exist, right? So it's gonna throw a null pointer exception. So it's gonna say start plus MPE, right? MPE. And then the finally block, which is this one, right? It's gonna say start, which is the one was before, MPE plus finally, which is here, right? And then of this try catch, this big one here is gonna say finished. And then return result, right? So let's see what happens. Okay. And whatever you return here will be printed here, right? So let's see what happens. This one is caption exception. Okay. Okay. As you can see, the number that was generated here, okay? Let me do something here. So we're gonna say this int b, right? And then we're gonna say int num, right? All right. And then we're gonna say Boolean b equals num this. All right, because I want to see this number. I want to see this number, right? So sys out the randomly generated number is, I want to see it, guys. Okay, so I'm going to run it again, right? So the random generated number is 0.68. So that is greater than 0.5. So that will be this guy. So it's gonna generate, it's gonna throw this exception. It comes up here, throw this exception and prints this. So that's what we get here, right? So that's what happened there. Now this guy here is calling this method, right? And it's doing all this. Then it continues here and says result start, right? Right? Then str is null. Okay? As it is null, it's going to say start MPE, right? And then it's going to say finally, right? And it's going to throw the exception here of this entire try catch and say, remember that we have an exception here. We have exceptions here that are thrown. This guy catches that and adds finished to the string. And that's why we get this, right? If we just do this, right, this will never be executed, right? So if I do this, I get a completely different guy here. I got start, I got end, I got finally, and I got finished. But I never got MPE, because this does not execute. There's no null pointer exception, right? And as you can see here, 0.48, it's a number that is smaller than 0.5. That's why this exception is thrown, and then it's going to print closed, right? That's why we are closed here. So do you guys understand it? I think that if you give it some thought, you will understand it. It's not difficult to understand. It's just a sequence of events that happen here, right? And then the Java version machine would read this and trying to, catch the exceptions that accordingly, the ones that happen, and then it's going to execute the block that is in the exception, and then continue run the program.
I have a question. Line 32.
Mm-hmm.
What
you want to catch this? You want to catch it here, right? You want to print this guy. So if
isn't that part of the try? Isn't that part of the try?
If you comment that, right?
It's still executed.
Yeah, nothing happens. If you comment this, it's just
So you don't need.
Finish will never be executed. So here, right? You know why finish not executed? But finish here. Okay? But if I just do this, it doesn't catch it. So forget about this line. Let's just think that imagine this line doesn't exist, right? Let's think that this line doesn't exist, right? So finish will never be printed because there's no exception thrown in this block here. Remember, you have a nested try catch. You mean you have one inside one, right? If there's no exception thrown here, right, there will not be an exception to catch out here.
Oh, I see. I see where you're coming from.
So now, when you throw it, just forcing it because you want to force it.
Exactly. You're basically forcing the exception.
Yeah. So something has to catch it, right? Something has to catch it. Remember that if you put something here inside here, right? And if you just comment this out, nothing will happen. Remember this one, after this one, finally will be executed, right? Finally will always be executed, no matter what, okay? If I have this guy here, but this never happens, right?
So it's going to run it's going to finish it. It's going to run the, no?
It doesn't. Remember that there's no.
Oh yeah, the null point exception is not running.
Correct. Yes. So this block is never executed. That's why it will not throw the exception. But as you're putting it in the finally is always executed, no matter what. So now it doesn't matter if there's no point exception. Still, it prints finished, because finally is always executed. Here, if I do this, still finished, will be printed, right? Because this exception is never caught, and it would not add MPE. This is executed. because there's no null pointer exception. You see, it's just it's just a chain of events, right? That will happen only and only when the exception is caught. If the exception is never caught, the block of the exception of the catch will never be executed. Finally, it's always executed no matter what. Okay, so whatever I put in finally, you can put whatever you want. I have been printed no matter what, right? It will always be printed, whether there is an exception or not. It will always be printed. Okay. You got it?
Yep, I got it.
How about the rest of the class?
The what?
The rest of the class. Is there anyone else here with us? Or is only you and me, Maria? Anang is too quiet. Mr. C, are you there?
Yeah, I'm here.
Okay.
You hear me?
Yes, yes.
Okay.
So that's dealing with exception. Let's see an exception with a return. Okay. Let's see an exception with a return.
Yeah, I'll hold one more question.
Go ahead.
Go down, 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 down. Where is this return? Line 36 here.
All this?
Uh-huh.
You're returning results.
From where?
Where? Here.
Oh, from calculate. Okay, got it.
Yeah.
I didn't see.
You could have done this, right? What are you returning? A string, right? You're returning a string, right? Where is it? It's a string, right? So you can
Result.
say, you can say,
Yeah.
you can say here, string,
Mm-hmm.
return value, right? Right? You can do that if you want to. Right? And here, just put return value. Right? So it's the same thing. We're just calling the method directly. Right? We just put the method in the print statement. It's the same thing. Right? But let's keep it the other way. Right? Same thing. Right? So whatever you return here is being printed in this statement. Okay. You got it, Maria?
Sí, sí. Lo que pasa, I have not seen the string value on the calculate method.
Right, right. But you
I
can
thought it
do
was a void.
you can do it both ways, right? You can say like this, public static Boolean return Boolean, right? Right? And say return true, right? And we can here in the main method, you can say system out return Boolean, right?
Mm-hmm.
And that's gonna print true, right? Right here, right? Or you can simply say,
I understood that it was a void for some reason. The calculate was a void.
no, calculation string.
Yeah.
String right here.
I get it.
No, if it is a void, it gives you an error here. The void doesn't have a return statement. Okay. You can see Boolean B or Boolean C, and then return Boolean, right? And then here say C, same thing. Two different ways to do it. But this one is more efficient than the other one. Why? Because if you want to use this value in C again throughout the program, you don't have to call the method again. Okay? You just have to call it once and then that's it. Otherwise, you have to call return Boolean every time they want to use the value that is returned from this method, right? So you don't want to do that. Okay. Okay. Now let's see catch with a return. Catch with a return. Right? Catch with a return. Right? So now I'm going to say sys out. We're going to do exactly the same, Maria. Calculate. Right? And then outside of the method we say public. But this time, instead of string, we're going to return an integer, right? And then we say this, return whatever you want to return. But first, we want to do a try catch, right? We want to return 10 divided by 1, right? And then we're going to say catch. What is the exception that is caught when you divide a number? Remember, guys, what is the exception?
Arithmetic.
Correct. Arithmetic exception, right? And then we say sys out error. And then we say system, and what you're doing here is exit, right? When you see system.exit, we're exiting, right? We're just exiting with status 0. We're just exiting, right? And then we can say return 1, right? Now we can say finally, and we say sys out, finally, and when we return a 0. Okay? So now let's see this. Let's see what happens. And we get this guy here. We get a finally and a 0. Remember that 10 divided by 1 is what?
It's correct. It's 10.
It's 10, right?
Yeah, it's divided by the same number. So
it's 10. But we're not printing 10 here, right? So what's going to happen is it's not going to catch any exception because there's no exception thrown here.
Yeah, it's a valid math.
Yeah, 10 divided by 1 is a valid operation. So it would not execute this block, right? So it will come to the finally and print 0, return 0. So it prints finally and returns 0. This is the number that we are printing here, 0, right? But what if I do this, right? And then we get error, right? But the final is not printed. Why not? The final is
because you exit before.
Oh, right. So we're simply saying stop all the operations from now on. Nothing else is printed. We're just exiting the program.
So it's system.exit and exit out completely out of the program. In other words,
correct. If it doesn't exit, what it does, it prints the finally. Right? If we just do this, it returns error, finally, and 0. right?
Yep.
Right? So we put here 1, and what do we get? We still do this. So this number doesn't make any difference. Right? You see? We just exited, but it takes a parameter. Right? It there's an argument. We do this. You see? It takes an argument. It says expected 1, but found 0. So you have to give it a number. Right? Let's say 0. Right? And then it will stop everything and not print finally. Right? What if we put it here? Press finally and doesn't print 0. Right? Right? Remember that when you have in Java, you could now return 2 values at the same time. You return only 1. That's why 1 never shows. You see that 1 never shows? Why? Because it will return the last one that it finds. It will not return both. It only returns 1 value. If I just comment this out and I just print it, you see, it will never print 1 because it will print the last one. Right? It returns 1, but then after that, it returns 0. So 1 is completely eliminated. Right? What if we have this? Like probably this guy here. Right? Finally only. Because this exception is never called. Okay, so that's a return. So you can return something with that if you want. You can put whatever you want, guys, in the catch block, whatever you want. Okay, it's just whatever you want. You can return whatever you want. You can put whatever you want. It's just a choice, right? You have a choice. But this is catch with return. Okay. Okay, let's see one more. This time we're gonna see let me see here. Methods with exceptions. Okay. Right. And before this class, I'm going to create a class name, no more meet exception. Extends exception. Okay. It's going to be this class, right? The other class is going to be no more plans exception. And it extends runtime exception. Right? Remember, this for unchecked exceptions, this one is for checked exceptions. Okay? Exception, runtime. Okay, they both come from exception, but this one originates from runtime exception. Okay. After this, I'm going to create an interface, and I'm going to call it omnivore. Okay. In this interface, I'm going to have void it meet, right? That takes an amount and throws no more meet exception, right? And void eat plants, and you know what's going to happen now, right? Nothing happens, okay? It's not going to throw no more plants exception, okay? So now we're going to create a class named bear that implements omnivore, right? And of course, you have to bring these guys, you know. So we're going to say eat meat, right? And we're going to say eat plants, right? We have to implement those guys, right? Now we say public void eat meat int amount throws no more exception, right? And then we're going to say if the amount is less or equal to 0, right? We're going to throw new no more meet exception, right? If it is, so we're going to say eating meat, right? So we're going to throw that exception. Now in the other one, we're going to say if the amount is less or equals to 0, then we're going to say new throw no more plant exception. Okay. Oh. Okay. And then we're going to say sysout eating plants. Okay, perfect. So far, so good. So you guys understanding so far?
Yep.
Yeah. Now, we're going to work in the class methods with exception now. So we're going to say bear, create an object of the class bear. Create an object there. And then we say try, right? And then we say bear eat meat 2, right? As you can see, the amount is greater than 0. So what's going to happen here is going to throw and no more meet exception because it's less than 0. I'm sorry, this is not going to work, right? This is not going to be thrown, so it's going to say eating meat, right? Because the amount is greater than 0, so there's meat to eat, right? But now we're going to say bear eating plants is a -2. So when it calls this method here, right, it's going to say, well, it's less than 0. We're going to throw an exception here, right? And then it's going to come to this method here, no more plants, right? And it's going to do the following now, okay? It's going to do the following now. So we come here and we say catch. We say no more plant exception. right? And we're gonna say, well, let's print the print stack, okay? All the chain of events that happen when that exception happens, okay? And we're gonna say this out, no more plants, right? The other catch is gonna be a runtime exception. And then we're gonna say this out, runtime, right? And then we're gonna have another catch that says no more meet exception. And then we're gonna say the print stack trace and says this out, no more, or bears hungry, no more bears hungry. Okay. And then we say finally, this out, finally. Okay. So guys, if you take a look at this, this is the meat and potato of this whole thing. Okay. If this guy is less than 0, which is the case here, okay, it's gonna throw that exception and it's gonna say no more plants, it's gonna say no more plants, right? This guy is greater than 0, so the exception will not be thrown because is greater than 0. So let's run this guy, let's see what happens. Let's see what we get here. Okay, right? So when we get here, eating meat, right? It's because this is never true. If it is never true, this is not executed. So this guy will be executed, eating plants, right? That's what we have here, right? But the amount of plants is less than 0. So what it means is this is gonna be true, right? It's gonna throw this exception. It's gonna come here to where the exception is, which is right here. It will print the stack, which is this, right? And it will print no more plants, right? And then it will print finally, right? Because the finally is always printed. Now, if I do this, right? Let's see what happens. Right? So we get no more meat. We get no more meat. It's right here. No more meat exception. Okay. Right here. It prints this stack. Right? It says bears hungry. And it says finally. See that it never prints. It never gets to this guy. It never gets to this guy. Because this is already, it's already get the catches the exception here. And then the program ends after this guy here. That's it. Right? Now, if I just comment this out, see what happens here. Of course, I cannot do that because I have this catch here. Right? I have this catch here. Okay. Sorry. I have it here. Why did it appear? Oh. Okay. I made this too. Now, if I make this here, we have eating plant, eating meat, eating plants, and finally. Why? Because these exceptions are never caught. They're never caught. So basically, there's no exceptions to catch. Right? So it will print eating plants, eating meat, eating plants, and finally. Okay. If I do this, it just prints eating meat because there's meat, right? There's meat here. It will print no more plants, right? It prints finally, and then it prints the stack at the end of this guy here. I don't know if you guys understand what I'm saying here.
I am good.
Hmm?
I am good.
Yeah, how about the other 6 students? I have 6 students other than you. Actually, I have 5. Okay. Let me commit this to GitHub real quick. Okay. Let me just commit this, clear. And let me CD, one moment. CD desktop, real quick. CD desktop. And then let me add, git commit, and let's say understanding exceptions, checked versus unchecked exceptions, dealing with exceptions using finally caching exceptions, catch will return methods with exceptions. Git push. Done. So now I can come here to GitHub and I can see that this guy has been updated. Exception handling, all of them are here. Okay, perfect. Let's do something real quick. Okay. So let me go to Waze Labs.